Welcome to OpenCV tutorial. My name is Richard Kirschner from the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. And we're going to be going over the OpenCV tutorial. And it's going to throw in some karate, and we're actually going to be covering a lot of ground in this tutorial. So I'll speed up for some of it and slow down as we focus on important aspects. When we talk about OpenCV, we're really talking about computer vision. So what is computer vision? And I would say OpenCV goes way beyond computer vision. It goes into graphic editors and all kinds of other things. But we're going to be focusing a little bit on computer vision, and we're going to cover the whole slew of the editors and all the other cool stuff that's in there. Computer vision is a field of machine learning whose goal is to help computers see. Its end goal is to make intelligent systems which can understand digital images. And there's all kinds of different examples, from handwriting, identification, categorizing of pictures, is that a dog or a cat in the picture, and all that different things. Those are all part of the computer vision. Cars, the new automated cars, and being able to drive down the road, they usually use aspects of computer vision to do that for our AIs. So what is OpenCV? OpenCV is a huge open source library for computer vision, machine learning, and image processing. It can be used to process images and videos, to identify objects, faces, or even handwriting of a human. And one of the cool things is the OpenCV project is outside of Python, but it has a high integration with Python. So you can use it in other programming languages. You're not set to just Python with it. And it has a huge community behind it, which is really nice. That's what makes the OpenCV project so great. We'll start with installing the OpenCV. It's pretty straightforward. In Python, you do a pip install opencv-python. You can pip install OpenCV contrib python headless. OpenCV can be installed in Windows, Mac OS, or any GNU Linux distribution by using the pip command. The first command we went over is to install the main module packages, and the second one is for the full package. And usually you want the full package. Once you start digging into it, it's so easy to use, and there's so much fun things you can play with. So the most common thing is reading in image in OpenCV. And we'll do this also in code. So if I go a little quick on the slides, it's so that we can roll up our sleeves and actually open up and do the coding on there. So when we're reading an image in an OpenCV, given an image to load it in, we can use the OpenCV function IamRead. The image can be displayed using the function IamShow. And so these are your two main categories on here. And so your basic thing is to read an image in, then you can manipulate it, and then you can display it depending on what you're using it for. And then when we talk about manipulating it, the most common thing is probably resizing images and videos. So you can read in videos, and we'll look at the command for that also, and how you can process them frame by frame. Resizing is helpful in all kinds of aspects. Obviously on the display, you might want to resize it so it fits the display a certain way. A lot of times that's handled for the size of the image. If you're uploading it to the web, you might want to have a smaller image so you're not taking up a huge amount of memory. Not as big of a deal anymore, and then a lot of times the actual web page would handle the size of the image once you upload it. But what if you want to process all the images under the same neural network? Well, they're going to look for the same size, and that's also is huge, just to be able to resize your images to go into that neural network, so you're not looking at different sized images. And images read in might not be of correct size or might not fit the screen correctly. To overcome this, we can resize the image, and you can see it's a real simple command in the CV. And we're actually using what they call CV2. A lot of times people will just they'll import CV2 or OpenCV2 as CV just to make it easy, because they might have old code or something like that, and it's easy to swap things in and move forward. And you can see here we just resize, we have our image, we have our new dimensions, and then how do we resize it? The interpolation is kind of a function in there as far as how to guess the colors, because you're combining colors and different things. And we can use drawing with the OpenCV. We can draw images in OpenCV. It allows us to draw various things like a rectangle, circles, lines. You can add text into the images and that kind of thing. So there's a whole slew of different things we can do with the OpenCV. And we'll look at these commands. We'll glance through them and show you how they work in the actual software. And they have basic image functions. And this is just so cool because so much of this is built in. You go back 10 years and people are writing the code to do this stuff, and now it's all built in and people are continually optimizing it. So you can do a lot of things without having to lift the hood up and really do the heavy lifting underneath. And so OpenCV has built-in functions which allow us to perform various operations on our images, such as blurring, resizing, cascading, edge detection, and cropping. And there's also motion detection in videos. There's all kinds of things. And you can see here we have blurring, where you can take an image and blur it slightly. We can resize it. It's easy to crop it, that we can do the little round head face cropping on a web page or whatever. Or identify where the object is and crop the background out, kind of thing. And then you have image transformation. We talked a little bit just a second ago on blurring. We can also do things like rotating it. We can transform the image various ways. You can see here we can shift it. So we can shift it left, shift it right, flip it, crop it. All of these are very easy to do in the OpenCV package. And then I mentioned a little bit about, we start looking at motion detection and detecting different things. There's contour detection, which is built into the OpenCV package, which is really nice. And again, this is stuff that usually was somebody in the back end programming this, and now you have OpenCV, which does almost everything for you. So a contour is a curve or a line joining all points which have the same color or intensity. Contours help us find the points which lie on the same plane and assist in edge detection. And you can see here we've taken the cat and done a contour detection, and it kind of makes it look almost like someone stenciled it in there. So it's kind of cool, little Zen art going on there. This is how the computer might, using contour detection, see the cat on the black background. And then you also can adjust the color channels. So you can play with all the colors. Any image is basically a combination of three main colors: red, green, blue, the RGB. Sometimes a quick note, which we won't cover in the programming, is when you see that RGB, it's not always in that order. There's different formats for it, and there's also sometimes the alpha channel. So you might have RGB-A, where A is how transparent it is. So you might actually have 4 channels, which I like to work with when trying to take the background out, because the edges of images actually have reflections, and light is also a curve and wraps around. So there's some cool things to note when you're messing with these things. And the OpenCV allows us to split our image into its respective color channels. And you can see here we've taken the image of a little landscape and we've sorted it out into different channels, and you can see how you have it all in the blues, the reds, and the greens. And there's also color spaces. Color spaces are a way to represent the color channels present in an image. They tell us the various color channels which are contributing to a particular hue. So again, we can pull things out based on the hue and the images and colors on there. And blurring. Blurring is very popular right now because it's easy to find someone's face and then blur out the background without having to play with alpha channels and different things for the coloring around the, you have the edging of the head and the coloring. So blurring is a method used to remove noise from an image by applying a low pass filter over an image. We smooth out the edges and make the transition from one color to another very smooth. And you might not be able to see the difference in the cat video, but you start seeing smoothness and sharpness have always been a mainstay of editing images and things like that over the years. And so this is all built into OpenCV. And then there's bitwise operations. Bitwise operations are the and, or, zor, etc. in image processing. They are used to create a new image or for masking. And we'll glance at masking, but masking is huge. So when we get into the code, we'll talk a little bit more about masking. I'll probably maybe offshoot for a minute on that. The operation is done between each pixel of 2 images. And so you can see here we have the square plus the circle. So if it's an and, only where the white is. So where it's in both images, it then equals a new image with just the white parts. In masking, Masking is used to bring certain parts of an image into focus by lowering the definition over other parts. This is done by reducing the pixel quality of other parts of the image. Kind of a little short on the masking of what it is. So in this case, the masking would either be the background, might be all ones, and the cat in the fence might be zeros, or vice versa. We might put the cat as 1 and the background as zeros. And then you can do a transformation on either the background or the foreground to, maybe you want to blur the background out and make the foreground sharper. Or maybe you want to make the little circle with the cat in it, take the colors out so he's one color. Masking allows you to separate your image out and do those different things, and that's where the masking comes in. And it has a lot of uses. And then there's histograms. Histograms, in an image processing, histograms typically refer to a graph of pixel intensity values. The intensity of each pixel is plotted in a histogram. Again, we start with these histograms are the beginning of doing different identifications and can be used for different things. You don't really publish a histogram onto your web page of the cats because it's just kind of silly, but you can use that data in data processing to look at different things and pull different things out of the picture. Thresholding, another important aspect of image processing. A method of image segmentation. It is used to convert an image of binary by setting a threshold intensity value and deeming all values above it as 1 converted to white and below as 0 black. And you can see here we were talking about masks. In the threshold, we're able to actually create a mask of the image. In this case, you have the cats, which are mostly white, stand out because we put whatever the value is to pull those cats out and put the background further back. Edge detection. Just like threshold, it's another tool we can use to bring out an image. So we can find different things on there. A lot of cool things we can do with that. You can see here we've taken a landscape, same one we had before, and we can find the boundaries of an image by consistency and brightness. It's used for image segmentation and data extraction. And you can see with this image of the buildings how powerful it is just to pull the whole sky out. I mean, you know where the sky is. There's no debate on it. So finding edge detection has a lot of cool things it can do when you're processing images and pulling the images apart. So with that, really the hands-on, there's so much hands-on on this. So we're going to start with a real basic OpenCV setup in Python. We'll then take a look at some motion detection. I usually don't put the video on here because my office is under construction. You can see the partially finished wall in the back. When we do the motion detection, we'll have the video up and show you how to pull this video in, just like I'm doing here, and utilize that in a program. You can actually start detecting motions. You could think of a wilderness webcam or something like that, all kinds of fun things you can do with motion detection. And then we'll get into melding a little bit with the OpenCV and write a short Keras neural network that will train and do facial identification. So we're going to cover just a slew of really cool tools that you can do with OpenCV. So here's my favorite package to work in, the Anaconda. I'm going to be in Python 3.8. And then if you haven't yet, you need to go under environments. You can either install them through Anaconda here, or you can open up, let's see, where is it, 3.8. You can open up your terminal and do the pip install like we discussed earlier in the slide. And that was this slide right here, pip install OpenCV contrib Python headless. I would just go right for the second one because it installs everything. So it's the full package. And you would just go ahead and open up, in this case, Py38. There's my terminal window, and I can simply do my pip command in here. You can also, if you're in Anaconda, we can go in here, let's do all sorts of packages for OpenCV. And you can see here's your OpenCV, library OpenCV, Python OpenCV, and I actually installed all of these. All these are installed on my Anaconda for the use of this setup. Didn't want to miss anything. And then once we open this up, we're going to go in here to New and create a new Python window. Python 3. In this case, we're in 3.8, as I told you, which is what's set up in here. And we'll start with just OpenCV general. So let's put that in here, OpenCV. That's just a general setup on there for doing our OpenCV. And of course, some people like to, I'm not big on looking at my own face the whole time during these, but we'll go ahead and put my video back up there. And when we talk about the OpenCV, we want to go ahead and import all of our different aspects of what we're going to be working on in here. And you'll see on this, we have our import CV2. And I mentioned earlier that a lot of people, when they see the import CV2, they just go ahead and automatically do it as CV. That way, if you're using older code, it doesn't bother me too much to use CV2, but a lot of people prefer to just keep that as an open. Someday they'll probably have CV3, who knows. We want our numpy for our numbers array. Sometimes that comes in. We have our matplot library, kind of by default, and we'll do our matplot library inline just because we're in Jupyter Notebook. That way, if we do any plotting, it's not really going to affect what we're working on. I just do it as a standard. Pretty straightforward. And then before we get started, let me go ahead and pull over, we have a file set up on here with some images in it and some videos. And just like any of our other setups in Simplilearn, if you need a copy of some of these images, of course, it's pretty easy to come up with your own images and your own videos nowadays. But if you wanted to rerun this and set this up, you can certainly have them send the information over there with, in this case, we have the cat, which is going to be an image. We have a dog, which is going to be an MP4 video. And then we have, when we do facial recognition, we took some of our very well-known actors out there, like Ben Affleck, Elton John, the musician, Jerry Seinfeld, and other people. So we can actually train a Keras setup on there and do a facial recognition on there. And again, all of this you can send to Simplilearn and say, hey, can I get a copy of some of this information? And so we're going to start out, the first thing we want to do is just the most basic thing, which is read in an image and display it. And then I'm going to go ahead and, let's see, I'm going to cut this in half. I used to have this in Windows 10 where I just hit a button and it dropped my background and everything. So we're going to look at the horrible blue color of the Windows default. You'll just have to ignore my icons up there. And so we're going to be reading images. And the reason I did a half screen here is because when they pop up, they don't necessarily pop up by default in front in the Jupyter Notebook. So you're not even going to see them. They'd be hidden behind there. The first thing we want to do is just a basic reading of an image. In this case, we're just going to read the file cat.jpg. There's no path in here because I went ahead and saved it in the same folder that the program's running in. But if you have it in a separate folder, you want to put that full path in there. And so it's real simple. We have image, we have cm.imread or read. I don't know which one they use. imread. And then cv imshow. Image, and that just stands for image show, and cats, and then image. Cats is the title of the window that's going to pop up. And let's go ahead and run that. And you can see here we have our window that pops up, and there's our cat. So that's really straightforward. If you're looking at that, there's nothing really difficult. And this is why I like OpenCV so much, because it's so easy to use. And if we're going to do the image, if you remember we had dog video going on. Let me move my image up a little bit. There we go. We can go ahead and play a movie, and that is really cool. And by the way, when I was messing with this, it does actually store the sound file with the MP4. So if you have the video playing and the microphone going, it will store both of those as a separate. There's like another channel that stores in the CV when it's reading these things. In this case, we're going to go ahead and capture. We need to go ahead and tell it what file we're capturing. In the next video, we'll actually do one of the next two sections. We'll show you how to capture the camera you're actually looking at. But in this one, we have capture CB video capture dog.mp4. Pretty straightforward. It just says here's the file we're going to capture. And then it says while true, And this, if you're doing a lot of programming in Python, you should recognize this. Instead of setting is true to true and then letting it switch each time, we just say, hey, if not is true, break, and that will break the loop. And so what we're doing here is we're going to read each frame of the video as it goes. Is true frame equals capture.read. If is true is false, it breaks, so we're done. We've hit the end of the video. And then we're going to show the video, in this case of the dog, cute little puppy. And it's going to be by frame. So each frame is shown. And you see we have a wait key here. This has to do with the encode in the back. So you could probably leave it out in here, but it's usually good to leave these particular things in. This particular key in there, because it does actually, there are times when that can affect the runtime. And you can see here's our little puppers, smiling and having fun. And it's playing each of those frames. So as you're watching it, it's going through, I don't know how many frames per second, probably 30 frames per second. And so it's displaying 30 frames one after another. And if you have sound with it, by default will play the soundtrack with there, just so you know. We're not doing too much in sound on this one, that we're just focusing on the OpenCV video. And then when you're done with something, you'll see me flash this up a bunch of times. We're going to have the destroy all windows from the CV, which closes everything we got going. When we're dealing with videos, one of the issues is you have a buffer in your video. And so you'll see this kind of coding where it says wait key 60. And it's just waiting an extra period of time to make sure everything's cleared out of memory. That's all that does. And so you can see we just closed all the windows that came in on there. And then one of the cool things we can do, and we're going to do a bunch of stuff with images in just a minute, but let's start with the video. We can do resizing. And so we have a rescale the frame. We're going to send it the frame, we're going to send it the scale, and it's going to compute the height, the width and the height based on what we send for a scale. We'll put it into dimensions, and this right here is our resize. CF resize the frame, and this could also be an image. You're not stuck with just a frame when you do this kind of resize. And then this is the code they use for resizing. Not a whole lot to look in there. It does come up sometimes because there are a couple different mathematical codes of how to blend the colors together and make it smaller without it becoming really chunky or really, they used to just delete, like if you cut it in half, you just delete every other pixel. And then, of course, you're deleting information instead of melding it together. And this smooths it over. That's what this is doing right here, this interpolation equals CV inter area. And then we have the change the res. We're going to be doing a live video, so when you change the resolution, again, there's not a whole lot to look in here. It's just helping us so that the resolution keeps it looking nice on there. And then we have this should look familiar from above. We do our capture. We need to set up where the video is coming from. We got to let the CV, the OpenCV, know what which file it's using. And then it says while true. This is again just like above. If not is true, break. And here's our frame resize. And then we're going to do CV IMShow frame, and then we're going to do CV IMShow framed resize. This should look just like you saw before. And then we have our this extra code here in case we need to break early. Now I'm going to run this, and we're going to get if you're looking at this, you should say, oh, we have two different videos going. One of them is labeled video, and it's based on frame, and one is video resized based on frame. So we're going to end up with two completely separate videos playing at the same time. And let's go ahead and run and see what that looks like. You'll know one of the videos is obviously going to be the dog because we saw him before, and you can see right here, there the dog is resized. And we could easily take this scale. Yeah, we'll go this way just a little bit. And instead of 0.5, maybe we want to do 0.25 because we want it to be like a little little thumbnail on there. Let me run that. And you can see how it nicely rescales it down to 1/4 of the size. And then I'm going to keep the split screen. You'll see why in just a second. Let me go ahead and destroy the windows and clean up our desktop that we're working on. And we're going to go back to image editing. So we're going to go through a bunch of different editings you can do on here. Now, this next part, we're zooming through. There are so many things you can do with the OpenCV. First, we're going to just draw a blank box. We'll go ahead and run this. Here's my blank box. It's got nothing in it. And we can take, if you notice, I've created blank. Oops, there's my blank. We filled it with zeros. So this is a 500 by 500 by 3 channel. There's actually can be 4 channels if you have the alpha, which is a see-through. And this will handle an alpha channel. But you have the 3 channels in here, and you create a nice blank box. It's just black in there. And then if we're going to do a blank box, we can actually take, let me go back in here. There we go. We're going to take this blank box, and we're just going to fill it. I'll leave it called blank. We'll run this, and I'm putting in from 200 to 300. That's actual pixel counts. Remember, this is a 500 by 500 box. And we're going to do from 200 to 300 and 300 to 400. That's the upper left and bottom right corners of the array. And we're going to send them to 0, 0, 255, which happens to be green. And this is RBG. Be a little careful because some of the formats switch the order from red, blue, green to different colors. And if we run this, you can see here we've actually added, oh, I guess I did a red box. For some reason I thought that was a green color. I must have it switched around on there. But you can see right here that we can actually go in and we can change any pixel in here. And it works like a numpy array, which is really nice because now I can edit my blank box here and do different things in the blank box and fill it in there and draw lines. We'll go ahead and do a rectangle. Like I said, some of this is going to be quicker to pasting in here and showing you. We're going to take a rectangle and, oops, it's hard to see here. Create the shape. Let me open this up a little wider. There we go. And in the rectangle, we're going to use blank. I'm going to show it. We're going to give it a new window. That's what this is doing down here. If I left this blank, it just put the rectangle on top of everything. And we're going to use blank as our basis, starting at 0, 0. And you can see our different dimensions and thickness -1. And there's my weight key on the bottom. And let me go ahead and run that. Oops, I should have done an IM show, which it did, but it was behind our Chrome. You can set where it appears on the window. We should probably do that on here. But you can see it opened up a new window. This window is called rectangle. This one's called blank. And so these are 2 completely different windows that we've set up on here. If I had changed this to blank, it would have just put the rectangle on top, just like it did the red square earlier. And we can do a lot with this. We can go ahead and draw, let's see, a circle, a line, and then put some text on here. And we'll take the same blank setup, since that's our basis right here is blank, and we'll go ahead and create all of those. And let me go ahead and paste that in here. And you can see here we have our CV circle. It's going in on the blank. We have our dimensions of the circle. Let me just bring these down a line so you can see a little bit better what we're looking at. There we go. And then we're going to do the color on this, the thickness -1. And this is basically a radius of the circle kind of setup. I'd have to look up to remember the exact what these different numbers represent. But you have the different sizes of the circle. We have a line here. We're going to draw a line blank. In this case, we have 300, 400, 255, and you can see a setup in here. This is again the color, the starting point, the end point, and a thickness of 3. So a lot of this is pretty straightforward, and this is going to open up a new window called line, because that's what we called it instead of putting it on the blank. And then we'll do text. Now on each one of these, we're adding the line to blank, so it's in the original blank square that we've called blank. But on each one of these, we're opening it up in a new window. we could easily continue to put them in the same window, and you could turn it into a video or some other kind of thing. And you can see down here, hello, my name is Jason. My name isn't actually Jason. And we have our location that we're going to print Jason on there, and the font and the size and the color and dimensions of it, and then show text. And let's go ahead and run so you can see how all these show up on here. And if I open up my screen a little wider, you can see that we have our code, and we did certainly add a circle on here. Here's our circle. We added a line on here. Here's our line. And we've added text on here. Hello, my name is Jason. Probably should have picked a different color instead of matching it with the square box we put on there. And just like all of this, we want to go ahead and clear the data. Keep a nice clean screen. And I'm not sure why it keeps printing this stuff underneath. I gotta go fix that. And the next section we want to cover is going to be your grayscales and blending and masking and stuff like that. And let's go ahead and clear our little palette. I don't know what else to call it. That's a good name for it, palette. And here we go. You remember this one. We're going to load our image. In this case, we're going to load the image park, and we're going to display park. We get that nice view of the park. That's what we did before. And there's so many things that are built into OpenCV on here. One, we can grayscale it. And we're just going to take, and you can see here we're converting blue, green, red. Remember I said there's 3 channels. You got to be a little careful what order they're in. I can never remember. I have to actually pull it up every time I go in here because I jump around between so many editors and software. It's just the nature of dealing with pictures sometimes. But you really have to make sure you catch that and double check it. And so we're just going to, this is just a conversion, and that's what the CVT stands for, color. And then we'll display this in grayscale it. And you can see it did a nice job. There's our park. Oops, if I can grab it. And there's the grayscale on there. And then we can do such things as blur. So I can come in here and we can go ahead and this uses CV Gaussian blur. And there's a lot of settings as far as how the blur works. And then you can see here we got border default, CV border default, 7.7. I believe that has to do with the square and the pixel range. When you do a lot of blurring, then you start messing with it. And we can see here's the park up here. We went ahead and grayscaled it. Oops, there we go. Gray not responding because I hit the wrong button on this. And blur. There's our blur on there. So we have a couple different setups on that. There's also edge cascade. Some of these you just pretty much, you really have to know you're editing on videos. I'm not a huge video editor. So when I do a lot of this stuff, I'm not really sure what it is I'm doing. Like I know what blur is obviously, but I don't know what edge cascade is. Except for now that it comes out, you can clearly see that it draws lines dealing with where the different colors meet and how they connect. That's a really neat tool. It puts a nice it literally creates a nice mask of the edging. And you could see where you could use this to pull out, in this case, the sky quite easily from the whole picture. And there's dilated. Let me go ahead and run that. We can see what that looks like. Oops, give it a second to pop up to the top. Keep in mind that the dilated used the edge as our input. So we took the canny, the blur. Oh, there we go. Yeah, canny blur. Dilated used the canny. So we have our blurred coming in from the canny edges. Quite the terminology there if you're trying to follow it all. We have eroding. Let me just show you some of the settings on there. We have the number of iterations for doing eroding. So let's go ahead and run this one. And you can see how it changes the settings or the view on there. And this brought in the dilated and then eroded it back into, I'm guessing it kind of sharpens it from the blurriness we saw in the one before it, the dilated. And then of course probably one of the ones that I use the most, and I use the resize. And the reason I use this a lot is because I work in data science. And so if I have it coming in as a certain size on there, if the neural network is processing an image with a certain size, all the images coming in have to be that size. And so we have here resizing our image. And let's go ahead and run that. And you can see how we took the, in this case, we used the original image and we just resized it to a smaller view on there. And if we can resize the image, we can also crop it. Again, data science loves cropping. This is, you could literally crop pictures and resize them and rotate them and make that your new input for doing categorization. And we'll actually show you how we can automate that when we get to the facial recognition Keras part of this tutorial. But we can see here we can also crop it. And we just take the picture and crop a small piece off of it there. And just like we did before, let's go ahead and clean our palette, start it over again. And again, we're just chugging through these. These are commands that, depending on what you're doing, depends on what you need. So if we're looking at changing it to grayscale, sometimes processing something in grayscale in Keras is easier. It's able to pull out the dimensions better. Blurring, that's more of a display kind of thing, where you're going to display it with a slight blur. Finding the edges, that's kind of cool. You can actually come in there and maybe use those edges to help you find something in the foreground and in the background. Dilated, give it that little blurry look. Eroded, bring it back into sharpness. Resize it and crop it. All those are things that are just neat tools to have at your fingertips and easy to use. Some of them might be more for a website and bringing up icons and cropping the headshot or something like that, where others are kind of more general use in just about any industry. Another feature is being able to translate. Transmat float 32. Remember, a lot of these things, let me just full screen this here real quick. We have our image coming in, and then we can translate it 100 in different directions on here. There's so many different things we can do with this. So as we go through this, oh my goodness, I hit a button on here. Okay, give me just a second. There we go. Okay, so let's go to translate. So I'm translate on there. And we have the cat, and you can see how we've translated it down instead of the full image of the cat that we had before. We can also rotate. Rotation, like I mentioned earlier, is a fun thing to do. And we'll actually do that when we do the Keras thing, because you can process the same image at different angles, and then you've just multiplied your input as far as doing identification. In this case, you can rotate on here. We have the angle, the rotation point, none. I believe it puts it in the center. I'd have to look that up. And then you have the image shape, height, width. Rotate point is none. Width, height. So this is actually going to put the rotate point in the middle. If we send it a none to this little routine that they put together in the back. And then we're going to warp. This is the actual command here, warp affine. And you have the image, you have your rotate map, and you have your dimensions on here. And if we go ahead and plug that in, and we put the rotate in image at -45, let's see what happens. And we're going to run that. And you can see how it nicely rotated the cat's head, although it's a little creepy the way it looks like it cut the cat's head off on there. Maybe move it, translate it down a notch, just so you can't see the cutoff point. And we already did the resize, but we'll run that again so you can see how it gets resized on here. And be aware when you resize them. I do a lot of resizing for putting it into neural networks or into some kind of machine learning setup, but it does squish it. It squishes it and stretches it, and so if you're doing this for, say, display and editing, you might want to be a little careful about that. Make sure that you maintain the same ratio unless you intentionally want the cat to look taller and thinner. And then we can also go ahead and flip it. As you can see here, we just flipped it upside down. -1, you can probably flip it a couple different ways. I'm curious as to what -2 does. Shoop, same thing. Maybe if we put and a 1 is not, well, 1 is just flipping it all the way to the opposite side from left to right. So you can see here we can flip it around a little bit. That's kind of a fun thing to have. One of those things you might have a hotkey for if you're doing some kind of picture editing and giving a lot of choices. And we also already did the See, there we go. Cropping. So you can see here where a cropped image equals the image, and we just pick out the pixels we want, and then we can show the cropped image over here. And it's just a cropping of the face. In this case, we grab 200 to 400 as the upper left corner and 300 to 400 as the bottom right corner. And let's clear our palette again. And then we're going to do contour detection. And there is so much that goes into all this. I mean, we're flashing through a lot of things, and you can see how you might combine them and use them for different things. So we're going to go ahead and get our cat back up as our image. And let's go ahead and do image shape. We're going to take an image shape and we're just going to create a blank screen for it. So this is just a blank screen here based on the shape of the cat. And strangely enough, this is done a lot. The reason that we would create a blank thing is or a blank image, is you might start filling in information on there and using that as your template for different things. And so it becomes a mask of sorts. There's an actual mask in the program, a little bit different, but you can imagine if this is your blank screen you start with, you might add circles or squares or whatever on there. And we can do the same thing here with, we can convert our picture to gray. We did that earlier, which is always kind of fun to see the cat comes back. And being that I'm messing with a lot of different feeds and stuff like that, it's you can see I got an auto-responding going on there. When you do a lot of this stuff, that's what you'll start seeing more of that as you mess with it. It'll eventually come in. You just got to give it some time. There it is. There comes in my gray one on there. And we have the Gaussian blur, so we can take it and blur the image. And in this case, we fed it the gray one. So you can see the very clear mouth underneath on the gray one, and then the more blurry one on top on there. If you remember, we did earlier, come back on here, canny edges. So again, we're doing detections and things like that and looking for different things. And there's another feature called CV threshold, or the CV threshold. And in this case, we're going to send it the gray picture. And let me just pull the coding down here. There we go. And you can see here we're going to do CV threshold based on binary. Let's set up on here, and we'll go ahead and just run this so you can see what this looks like. Run. There we go. That's actually really cool how it picks up on that, on the threshold. And you can see how it just turns it into almost a black and white image. That can be a lot of fun too. And we can also look at the contours in the OpenCV. So we talk about that. We have let me just open this up all the way so we can see the code. We're going to return the contours and the hierarchies. And we're going to pull this off of canny, the canny one that we sent up here earlier. And we have the retrieve list and chain approximate sample. So there's a lot of options in here that we can follow. Let's go ahead and run that. Let's go back down here. Where are you? Up there we go. And when we run this, we get a nice setup on this. It says, hey, there's 74 contours found on here. And that's actually starts turning this into a math on, whoops, which one did we feed it? We fed it the canny up here. So we start to look at these different setups. Let me get this out of the way. Where's canny? There's canny in the back. And you can see that this drew 74 different like line connections on here. So now we're starting to actually turn this into almost a mathematical formula on this. And while we're looking at these, we'll go ahead and do draw contours. And here's our contour. Let's return the contours up here. And we're going to put this on the blank. Remember how we did the blank earlier? So we are actually going to take the blank as, remember I told you could use it like a base setup on there, and we can now redraw the contours, but in this case we changed the color. So now we're drawing the contours in red. So that's just kind of a fun thing you can do on there to change the, literally change the appearance and the setup on there. And let's go, of course, clean up our setup, destroy all our windows, and move on to the next section. And we're going to look at color spaces. And let's start with, in the color spaces, we're going to read an image in. And I'm going to go ahead and show the image park. Let me just run that. Oops, I forgot to put the wait key in there. A lot of times the wait key just helps because I'm pushing all these graphics out through a single kernel because I'm working in Jupyter Notebook and things get hung up. And so waiting that extra 60 milliseconds can sometimes really help. Sometimes as we start flashing these pictures up and down, you'll see there's no response and other things come up. That really is just because we're pushing so much out there. Now one of the interesting things on this is we imported Matplot library. And so Matplot library can now easily be integrated with our imagery. And you can just see all we got to do is just dump the image into the Matplot library. And now I have the image here showing on my Matplot library setup. One of the things you're going to notice on this is the colors all look off. Well, again, you see that and you see that they're supposed to be the same thing. And you should jump and say, oh, one of these is RBG and the other is GBR or BGR or something like that. And so it's reading reading the colors in a different order. That's all that means. And you have to do a transformation at some point to fix that. So let's go ahead and take a look at, we'll go and go back and grayscale it again. We're going to take our image of the park. We'll put it into gray. Run. There we go. And in here we can convert our color, and this is what we were just talking about. We can convert the color scheme. Let me go ahead and run this. And you can see here we swapped the scheme out. And then I'm curious because we did up here plot it. What does this look like when we plot this new color down here? This new scheme. What does that look like on our setup? Let me go ahead and just go down. There we go. And we called this HSV. So we'll go down here and instead of image, I'm going to plot HSV. And let's run that. And still way off on color schemes. You can see we can really mess up with this. HSV is another type of color scheme. I was curious because I did not think it would come up correctly, but I wanted to see if it would. And we can also do a conversion to what's called, there we go, BGR, blue, green, red, to lab. And lab is just another color scheme on here. And so you can see when we swatch the color scheme, it has some really cool effects as far as what it looks like in their view. Lab ranges from, it's kind of luminosity, and then it has like then the channels coming in. So it's a little bit different setup on this, but really you have to just play with these to see what they look like. And we talk about all these different color schemes and all these switches on here. Now the one that we were talking about earlier I mentioned was the BGR to RGB, because we use the BGR. We'll just run this and we see the color change on that. And then we'll go back up because I'm still curious. Okay, there we go. Copy. If this is the same that Matplot library uses. And we'll just type in RGB down here because that's what we called our figure. And we'll run this and it will display it. Oops, it comes up there and gives us a problem because capitalization. Whoops. RGB, there we go. So let's go ahead and run that. And that looks pretty close to the original. So this is when we're converting between Matplot library and from the OpenCV, we really want the blue, green, red to red, green, blue. That's the conversion you want to use to get to the original picture on there. And then we can also convert from HSV to the lab. Like I said, these conversions, you have to look them up most of the time, but it's important to start recognizing them. So the very fact that you're in here looking at this, and we're talking about blue, green, red versus lab versus the, where was it, HSV setup on there. When you're dealing with pictures, they come in all varieties. And so really being able to switch between them is important on here. So let's go ahead and take that particular setup, conversions, and we'll go ahead and clean up our palette. Hopefully that will save us some problems down the road. And we're going to start looking at the color channels. And with this, we'll go ahead and reload the park back up. We'll display that just so you can remember what the original picture looked like. And then for right now, let's go ahead and take a blank screen and create ourselves a blank 0. It's basically the same shape as our park image. D-type, U integer 8. Don't really, usually that's the default anyway, so you don't really need to even put that in there, but it's good to have. And this is an interesting line here that OpenCV allows you to do. CV split image. And this basically just takes the 3 channels in your NumPy image, and you could use the NumPy code and figure it out, I'm sure, and splits it into blue channel, green channel, and red channel. And what we're going to do is we're going to go ahead and, there we go. We're going to do a CV merge, blue, green, and red. And what we're doing is we're merging the blank one as far as blue, the blank, green, blank, 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 red. So these are the new channels as we combine them. That's what this merge thing does. This is kind of fun because you could merge, you could take like your cat with just the red whiskers, merge that with something, and then kind of mess with the images as far as like, you know, what sticks out and what sets back on there. You can get pretty creative with the imagery. And then we're just going to go ahead and show blue, green, red. We'll just do all these at once. And you can see here, same image. Oops, there we go. I'll take it a second to pull it down. And we can now see it's either black or blue, red or blue, or, you know, the different colors in here, green or black. Kind of fun. I mean, you can really pull out the different colors and see how you can mess with them on there. And then if we go ahead and just do a quick print of these shapes, we go run. You can see here that, as you expected, you have the image shape, which is 427 640 by 3. Well, it's only 640 by 640, so each one of these is just the color of just the one color. That's all we're showing on here. The fact that we used the shape on here is very similar to your NumPy, and these are actually NumPy in the back end. So if you haven't messed with NumPy, real powerful setup on there. You can dive in there and do a lot of stuff in NumPy that comes back right into this over here. And then we'll merge them back in. Shoop. There we go. And we see the original picture. Give it a second to pop to the front. And you see here we merge the colors back. We separated the colors. We merge them back. Same image. And that's what we expect on this because we didn't mess with any of the colors. Let's go ahead and destroy all that. So we have another clear setup. And let's go in and look at some more alterations we can do with blurring and altering the image in different ways. For this, we'll go back to our cat picture. Here's our image, CV, AM red, cat JPEG. And if we run that and view it, there's our cat. I guess we got tired. I guess the guys in the back got tired of the cute puppy running around. And the first thing we'll go ahead and give a shot on here is averaging. These are different ways we can blur the image. So if we average it, it takes the average pixels based on 3 by 3. And if we change this to 30, just for fun, you can see how it really blurs it on there. So this is like a 30 by 30 pixel. Each pixel averages around it. We'll go back to 10. Kind of a little bit of fun stuff you can do on there. And you can see that because I'm doing the average blur, it knows to go to this frame right here. That's why I can so easily jump in here and just make some changes on that. That is a lot of fun when you're messing with videos because you can so easily throw that into your interface set up on there and be able to mess with it. And here's our Gaussian blur. And the Gaussian blur is very similar, but the pixels that are closer are given more weight. And let's just jump this up here to 30. We'll run that. And whoops, it didn't like 30. I guess I jumped too high for it. Let's do 5. There we go. You start to see the blurring on there. And then the one, let's change that and see what that does. Doesn't make a huge difference on this until you start messing with, let's see, weighted, there we go. Run. You start to see it starting to blur more and more depending on how we do the weight and how it kind of blends outward. Gaussian's nice because it adds a little bit more blending to it, where this just blurs it, where the average just blurs it out. Again, those are the kind of things you almost have to play with them a lot to start seeing how they change. And there's also the medium blur. Let's go ahead and run that one as it comes up. There we go. And the median works almost identical to the average. It's very similar on there. There are some differences. And you really have to start looking at what is the difference between an average and a median value. Because that's what this is based on. This is based on the median value. If we do a run 10, there we go, there's our median. Oh, it didn't like the 10. I'm not sure why. I must have been too high of a value for it. Run. Oops. Let's try 0.5. There we go. Okay, so, and this has to be an integer for the median blur. And you can see it's similar to the average, but there is a difference in the way the math actually functions in the background. Sometimes it comes out a little different. And there's also a bilateral filter. A lot of these you use to smooth sharp edges. If something looks really sharp, you can smooth it. And this is literally what they're doing when they say smooth something and you're messing around with Photoshop. These are the kind of changes that are happening in the back end. And then we have our bilateral. Let me go and run that. And the bilateral, that is one that's really important to remember because it works like the Gaussian, but it's like a Gaussian filter on top of a Gaussian filter. And one Gaussian filter smooths out like blotches, like if you want someone to have smooth skin, but keeps the sharp edges. And so when you're messing with this and you're doing a lot of work, remembering the bilateral filter is really important if you're doing images, especially if you look at my complexion, I really need it. I should be doing the bilateral on that one. That's the kind of thing that you'd be using to really bring up people's features while smoothing out all that fuzzy noise that shows up on their skin and blemishes. And again, let's go ahead and clear our palette. Run. Another cool feature, so we can do bitwise setup on here. And I'm going to create a blank setup just so you can see what it's going on there. Here's our blank box, 400, 400, 400. And it has a rectangle we're going to do from the blank copy, and then we're going to do a circle. The circle is going to be 200, 200 set up on here. So we're just building a circle and a rectangle like we did before. Let me just show you all the numbers on there so you can see what we're doing. Oops, let me maximize it. All right, there we go. Let me, always a question, do you do it before or after the comma? It really depends on what I'm working on and who I'm working with. I do whatever they want. So if it's sometimes it looks nice to have the commas in front, and sometimes afterwards when you're splitting rows, it's purely visual on here. So we're going to go ahead and build ourselves a rectangle and a circle here, and let's just go ahead and display those so we can see what those look like. So we're just going to show our two images. These images are based on the blank, so they're the same size as far as the image goes. And that's important when you're working with Bitwise. So how do you overlap two things if you don't know which parts are overlapping, so they have to be the same size? And we can see over here, let me just pull this over, we have our rectangle and our circle. And we can do just like we do with any kind of bitwise functionality. And let me pull, I guess, see if I can pull it over here without losing information on the screen. I always wish the screen was 10 times bigger than it ever is. It doesn't matter how big my screen is. So here we have the bitwise and. This is where the two regions intersect, and it's like you expect. You can see the white circle on the square, but where they're both at, but not where the black part is. So it's the and. They have to have both white on both the square and the circle. And just like that, we can also do the OR. And hopefully your mind's already jumped ahead. If we're doing the OR, CV bitwise OR, rectangle and circle, we have the combination of the two as if you just pasted one over the other in this particular case. And we have NOR, or ZOR as it's called, Control V. So it's not X nor or not Y. And if you look at that, that kind of makes a pretty pattern on there. Not X, not Y. Not X and Y, not. But that's the ZOR on there. You can see how the ZOR comes up on there. And then, of course, there's just the bitwise not on there. We'll go ahead and run that one. And you can see here where the not set up on that. In this case, it just inverses the circle from black to white. And just like before, let's go ahead and clear our palette. So we start with a clean palette over here. Also keeps my computer running smooth. And we're now into masking. Oh my gosh, I use masking so much. And if you go into any program out there that does any kind of editing, masking comes up. So we want to go ahead and work with our masking on this. And for masking, let's bring the cat back. Sure is a cute cat. In this case, we have a bunch of cute kittens. In fact, a bucket of cute kittens. That's a little scary. And we'll go ahead and create a blank page on here. And this is really interesting. In fact, I'm going to stop here and actually do a draw. And I want you to notice right there, whoops, right there is the 2, the shape. And this is a numpy shape. So what are we talking about with this numpy shape? Well, this numpy shape is zeros or ones. We're really looking for a black and white image. A lot of times when we talk about masks, we're talking about true false. And that is the same as in numpy, like a true false mask, just like you have in numpy. And we'll go ahead and create the blank image over here, and it's just like you'd think. It's black. And then we can easily do both the circle and rectangle. And you can see here we did an image shape. Yeah, this isn't too important right now because we're going to create the mask separately in just a second. But you can see where we're creating our image here. There we go. So you can see all the different things in the window. And it's going to create both a circle and a rectangle mask on here. And let's go ahead and do a bitwise. We're going to create the mask out of the bitwise, out of the circle and the square. We'll go ahead and run that so you can see what the mask looks like. And in fact, let's go back to, let's clear up our things. It gets our palette here. We'll just go run that. We're going to play with the, let's see, where are the kittens? Got to have our cute kittens on our display. There we go. There's our kittens. Come back. Okay, our bucket of kittens. That cracks me up, a bucket of kittens. And here's our mask run. You can see we have an interesting mask showing on there. And then we're gonna take and combine these. Let's see, here we go. And we're gonna do a bitwise where we have the image, and masked equals masked. So here's a bitwise setup on here. And let's see what that looks like. And it's just kind of fun. I've created this mask, adding all these things together, and you can see how easily we can actually just kind of zero in there and show just the kitten on the mask. So that's a lot of fun. And you could also reverse this and have an image without the kitten on there and just a black hole where the cat was. So those are both things that can happen on here. Let's go ahead and clear our setup. And masks can get so complicated. You can see we added 2 masks together, a square and a circle, and got a half circle on there. I tell you, I've gotten into so many layers of masks that I can't even track what's going on anymore. So you got to be a little careful with your masks and how you add them together and bring them together. But there's a lot of things you can do with them. You could just as easily swap the green channel in for one. So you have just certain areas where you have like just a circle or it's just green, or maybe the whole background is green and one area is actually full color. So there's a lot of cool things. Or you could mask, take the mask of a black and white image and then mask a section of it in color. I've seen that done to make some really cool photographs. Histograms, not something I normally think of when dealing with photographs, but you can do a histogram of the information on there. So let's bring back the kittens because they're just so cute. And let's grayscale it. Bring them back in our grayscaled cats. And then what we can do with this is we can go ahead and do a histogram on the grayscale. Boy, we can get so much into histograms because histograms have so much cool data that you can bring in. So a lot of times you can take images of something, you can start looking at the number of pixels, the bins that they fall in, different setups as it pulls in. But you can see we have a grayscale, the histogram of the grayscale here. And just like we do the grayscale, we can also do a histogram of the colored scale too. Boom, there we go. And the same setup, we got our plot figure, our title, we're just doing a histogram. We're just going to throw in the colors blue, green, red. And then we just go through each of the colors and we go ahead and mask them and then plot them on here. Let me just pull that over so you can easily see what's going on. And the same thing with the grayscale. All we did was come in here and just drop the grayscale right on here with the setup. And so we have our figure, our bins, and a number of pixels. And if we plot the red histogram of the colors, you can see here some really kind of fun patterns. And you could analyze these patterns on different things too. I don't know about kittens. I don't really think of kittens with histograms. Wouldn't really do a histogram of a cat. But you could see if this image was like a heartbeat image or something like that, the histogram would really be showing and telling you exactly what's going on. And we'll keep the cute kittens up there and look at thresholding. So we have the threshold, the thresh, and you can do a threshold on here. As far as, there we go, let me just bring that down so you can see some of the numbers that go into there. And we're going to use the grayscale and just do a simple thresholding view on here. And what we're looking at is the colors that come forward. You can do different thresholds on different colors. And here we're just saying, hey, if it's, because we're dealing with grays, if the certain color is over 150 or 255, you can see we have a nice, or if it's over 150, then it just turns it black, otherwise it's white. And so we create a nice threshold. And you could actually turn around and use this as a mask back on the original picture, and it would bring the cats out and make some interesting pictures on there. But that's a basic threshold on there. There's what they call an inverse threshold. Let's go ahead and take a look and see what that looks like so you have an idea. We'll run this. And this is just, you'll see right here, up here we had threshold gray, very similar. But when we get down to, there we go, thresh binary inverse, there's the key that changes it. So it's still is thresh inverse equals the same call, the same module CV threshold. It's just how do we process it on the end. And if we run that, if you guessed it, inverse means inverse, then you are correct. Oh, give it a second to pop back up here on top. There we go. So very similar to the original thresh inverse, but opposite. And also makes for kind of a cool picture. You could imagine taking either one of these and doing some cool things with them over the original pictures. And then finally there's an adaptive threshold on here. And the adaptive threshold, let me just pull that over here. There we go. It doesn't quite show up on this. We have adaptive threshold Gaussian, so we're going to use the Gaussian. If you remember, Gaussian means that it is slow to bring it up. Slow, that's not even quite the right word. There we go. Okay, I wanted to bring that over so you could see a little bit better. Gaussian means it's adaptive, so that the weight closest to the pixel is very different than as you get further and further away as far as adaptive threshold. And then the adaptive is based more on the difference between the pixels as opposed to the grayness on there. And let's go ahead and when we run it, let's take a look on this and see what that looks like. And we can see just quite the wild imagery. Again, it almost makes it like a black and white etching or something like that. So it kind of a really cool effect. So a lot of these things are designed to help find edges, which is our next section we're going to go over is pulling out the edges and finding the edge detection. And so you can see how complicated it is. It's not an easy thing to find the edges on these pictures. What is the edge? What are the colors? How do you find that? With the histogram we saw in the color scheme, how they did a certain setup, and you might be able to pull that information and use it to find an edge. And so there's a whole thing on edge detection. And this is so central to a lot of stuff being worked on now because, well, let's face it, if you're doing like any kind of imagery, you want to know where the edges are so you can draw a box around it, whether you're trying to program it to do a facial recognition, as we'll do in the third section we're going to cover. We're in the first section. But let's go ahead and bring back our park, run that. And we're also going to do a nice gray picture on here. Oops, let me put the weight key back in there. I don't know why it does not. When I run it without giving it that extra 60 milliseconds or whatever to pull it in there, it sure gives me a lot of problems on this machine. And again, it's because I'm doing the Jupyter Notebook. When I put this into a widget or something like that and start using OpenCV or use it as a backend for code, I don't see these kind of problems. It has a lot to do with just using it in Jupyter Notebook. And so let's start with the Sobel, the Sobel X, or the Sobel line detection on here. We're going to put in our grayscale setup on here. There's a lot of different settings on the Sobel X, Sobel Y, and combining them back together. So let's go ahead and take that. And we want to go ahead and show, oops, I forgot to bring my shows over. And I'm doing Sobel first, and the reason I wanted to do Sobel first is because the other one is based on the math behind Sobel that we're going to hit, the second one, which is which happens to be the Laplacian. And so this works on the intensity from one pixel to the next. And it kind of creates a formula for it. And as you can see, as we get into the intensity from one setup to the other, let me bring this down, we can start to see some lines in here. We have from the Y direction and the X direction, and we combine them, and you can see there's an interesting kind of pattern set up in here. Now, for a scene like the park, it's not really pulling it in that good. And like I said, each one of these has a different strength to it. With this one, you might do images a little bit better, close-up shots. But let's look at the Laplacian. Now the Laplacian is very similar to how it works in the background as the Sobel as far as intensity. But you take that formula for generating the intensity on there. And, whoops. What happened there? Okay, we take the intensity for the Laplacian. There it is. And they use the second derivative. And you can see how it really transforms the edges on this image. And there's a lot of things we could do with this. If you remember from earlier, we talked about taking out noise, blurring. If you use some of those features on here, like the foreground would just disappear with the right blurring technique or the right transposition technique. And it really becomes an art form trying to jump between all these and figure out which one's going to work for your picture and your setup on there. And then you run the histogram to kind of maybe try to find a mathematical thing behind it. It's really a challenge to take the background out or bring the background in and sort those things out. And all these tools are slowly being built, and that's what OpenCV works so good, just to address that. And then we already did the canny setup. We'll go ahead and run the line detection under canny. And the canny literally combines all of the different math functions of our the Laplacian and the Sobel setup. And you can see here it does a really good job of drawing lines and putting in areas on there. And again, this is just a starting point. One of the cool things you can do with here is blur it and then get rid of the bumps in the beginning and clean it up and do all kinds of things to create a mask on there. And let's go ahead and clean up our screen or pictures and images. And then we're going to dive into the second stage of this, which is motion detection. Now, we covered a huge amount in all these tools that they have on there, from our canny edge detection to bitwise mapping to masking. That's a lot of stuff to cover. Some of those tools we're going to use in the next setup, or one of the next two setups. But we're going to start with motion detection, which is kind of fun. If you have a web camera, or you have, there's all kinds of reasons you could use it. An outdoor webcam. That's what I've always wanted to put one up there because I live up in the mountains. It'd be fun to track the animals going by. But you could also use the motion detector to track somebody coming into an area and then do facial recognition on them. So you can see the motion detector has a lot of cool tools on there, and the fact that we're going to grab from the camera is really helpful also. So let's go ahead and go in here and open up a new, new Python 3, and we'll go ahead and rename this real quick. OpenCV motion detector. There we go. So let's dive into our motion detector, and there's so many. We're going to actually use a lot of the tools we looked at earlier. Let's go ahead and start by importing our OpenCV, and we went ahead and just did OpenCV2. Remember last time I said sometimes we leave it as CV or import CV2 as CV and so on. We're just going to import it as CV2 in this one. And we're going to do date time for tracking. We have this thing called static back. It's we want to be able to reset something to none, and so having it as a global variable here makes sense. And then I'm going to have current motion and motion list. And what it is a current motion is going to have a start time and an end time. That's when it detects a motion going on. And then the motion list is just going to keep tagging those on. So we have a new one and an ending one. Now we're looking at a lot of code here. So the first piece of code that's I really want to draw your attention to is this one right here. CV2.captureVideo. And then the number is, if you had multiple videos in here, you can actually capture the video off the different video cameras. And so we're looking for the main default one that's going to be set up in here. This is actually kind of cool because I always had the idea of having the front-facing camera and a side-facing camera so that you could flip between them and do different things as far as the final edit and that kind of thing. But this is the video. It's looking at this camera. We're just setting this up right now for which camera to look at. Now, when we're dealing with video, we're kind of creating an infinite loop, and so at some point we have to put a break in it, and we'll do that. We'll show you that break here in a second. In fact, I'm going to skip between the two and skip the code in the middle so you can see the beginning and the end. And so we have an infinite while loop, and we're going to stack images as the video goes and display them. And then when we get to the end of this infinite while loop, we need a way out. In other words, you don't want it just to go on forever until you hit the escape key. You could do that if you want. But we like to actually add something in there. And we'll go ahead and do, here we go. this. We're going to tag on the end here key weight, key Q2, and then just break. Now, this won't work like this unless we're actually displaying a video and that video screen is highlighted. All this says is if we are active in the active video screen when we do the display, when we get to that, break. Now I kind of jumped ahead because we actually have to create a display in the middle, but I wanted to put this all together so you could see it all in one shot here. We have our while loop we're working with. We're going to go ahead and initiate our frame outside of here. It says, hey, this is video. Whenever I do video, this is what we're looking at. Then we're going to read the video, and you'll have two returns on here, check and frame. And the frame is nothing more than the image coming in. That's what that is. And the check is, hey, do we have an image coming in? If you remember from earlier when we played the dog video, it came up with check would come out false when you got to the end of the video. Because this is an indefinite loop, we never do anything with the check. We don't have to worry about that too much. So here's our kind of our wrapper, and we're going to add a couple more things before the end of the break on this. And then we're going to initialize our motion. So up here I initialized the current motion as having nothing in it. So this is a current motion. There's no action going on. We haven't started an action. There's no end to the action. And then when these fill up, we'll put them into the motion list. And so we're going to go ahead and add in our motion equal to 0. So we're initializing the motion in the loop. And it starts out and says there's no motion going on. Now, we're going to go ahead and do some fun stuff here. And this stuff these next lines of code come off of what we just went over. We're going to grayscale it. Very straightforward. So whatever's coming in the camera is going to have a grayscale to it. And then we're going to do a Gaussian blur. This makes it easier to find the changes. We're looking for sharp edges that are moving. That's how we're going to do our motion detector. And if everything's a little blurry, that means the edges are going to stick out when they move because they're kind of blurring it to those edges. And then we're going to go ahead and do a if static back is none, static back equals gray. So we're going to assign our very first value to the first frame that comes in. That's all this is doing on here. And then continue on there. Now, I'm kind of zipping through these steps. I'm going to go back through them in just a second so that you'll make a little bit more understanding as we go. A difference between static background and the current frame, which is a Gaussian blur, so we want the difference between the two frames. And this is just kind of a fun, abstract way of finding, hey, what's the original frame and how much has it changed? And then if there's a change, and you're going to hopefully already have guessed that there's some problems with this piece of code right here. And I've run into this. What if your image is your outdoor cam and the grass is blowing in the wind? Or the lighting changes because the sun rises and sets. So it might work great in a room that has consistent lighting, not so good for a wilderness cam. And you've got to start thinking about these things, and there's ways around it. And if there's a change between the static background and the current frame is greater than 30, it will show white color. So this is kind of fun. Here's our first threshold. We're looking for a threshold between the background and the foreground. So we're starting to find a little bit there on the setup, and then we're going to go ahead and take our threshold frames, the difference from the background and the foreground, and we're going to put that into the thresh frame copy into a find contours, and we're going to use the chain approximate sample for finding the contours. So this is going to find some contours for us. And then what we want to look at is on the contours, so we're counting lines. We're counting how many contours or how many lines are in here. And if there's over 10,000 of these lines that are the difference between the initial frame and the new frame, then the motion's going to be 1. Wow, that's a lot to unpack. So let's go back up here and just go over that real quick, because I did each line as we went in there. First thing we're doing is we're converting it to gray. Why? It's easier to see gray. You can see the differences in movements and things like that in gray a lot better than in color. Next, we're going to blur the gray. This just makes it so it's easier to see the changes going on. We've reset our static back to none, so we initialize our background to gray. So if it's none, then we want the static back to be whatever the gray value is of our first frame. So when I turn the camera on, I'm going to be outside the camera, so you can see the back wall of my office, which is still under construction. Just a wall socket and some weird stuff back there. And that's what I'm going to use for my basic setup, and then when I go back in and move around, or actually I'll just be in it and just try to hold still and move around a little bit. And then we have the difference between the static background and the gray frame. So this is the gray frame coming in versus the static background. And then we take that and we make our threshold, and we basically create a bunch of lines. We find the contours of the threshold, the difference between those. And so that's where we get our nice lines, and if we have enough lines on there, then that means we have a motion equals 1. So that's a lot of fun. Motion equals 1. So the next stage is if we have a motion equals 1, we want to track it. And so we'll go ahead and do that here. Just throw that one in. And it says, hey, if this is a motion equals 1, and our current motion that we're looking at on our 0 slot has nothing in it, and the motion equals 1, then we want to go ahead and stamp the date time in there. So now we're tracking the start of movement. We have the beginning of movement. And we can do a bunch of really fun things. And this next part we're going to use for a bounding rectangle. And this is going to come up in a display we're going to show you in a second. This one, like, you know, tracking the current motion, you know, it's kind of cool. It's either 0 or 1. Really looking at the contour area and figuring out how much value to put this at. We put it at 10,000. That's really part of the OpenCV. Another thing with the OpenCV is we're going to start looking at these contours and we're going to create a rectangle around them. And then CV2 rectangle, we're just going to take the frame and write a rectangle right on top of that frame. Now, if for some reason I stop moving, we want to know about that. So now we've created a rectangle around movements, we've detected our motions. If it didn't detect any motions and there's nothing going on, then we want to go ahead and take and append the end time. So if motion equals 0 and current motion of 0 is not equal to an empty set, then we've had movement going on, and the current motion of 1 needs to equal the date time. We'll go ahead and just tag the current motion right on top, and then the current motion is reset to an empty set. So that's all it is we're just creating an array of the motions. And this is just kind of fun right now. We're going to go ahead and do displaying the images. We'll start with image gray frame. And there's our gray on there. And if you remember up here, we drew a box on it. So you're going to start seeing the rectangle on the frame coming in. And then we're going to go and start displaying the gray frame because we converted everything to frame. We want to go ahead and display the differential. So you can see what's going on in there and why that looks different. And we want to display both the threshold frame and the color frame. So we're going to do all of these up here. There we go. Okay. So we basically are showing up everything that we've put together so that it's going to show up on the screen in little boxes. And then we have our key weight. And I said I need to fill some more stuff in here. Well, if we're in the middle of detection of motion and I hit the Q button, it'll be nice to know that. It'd be nice to tag that on to the end. So we'll go ahead and tag that on to the end here. And if motion equals 1 and current motion of 0 is not equal to an empty set, then current motion of 1 equals date time now. And motionless append the current motion. And then break. That takes us out of the loop completely. And then once we hit the brake, we'd like to see what's going on with our motion list. That's what it's all about, is the motion list. So we'll do a quick display on our motion list. I don't want to go past 30 if I do too many start and stops. This is important. Let me go ahead and highlight this right here. We want to release the video and of course destroy all our windows. Okay, and that's just cleaning up. Always good to clean up on there. And these are nothing more. Let me go back up to the top. Here we go. We've already talked a lot about the show. So we're showing the gray frame that we created. We're showing the difference frame that we created. We're showing the threshold frame. And then we're showing the actual color frame that's actually coming in, the frame that's coming in. So, wow, that's a lot to break down. Let's go ahead and run it. Hopefully I didn't miss something when I was coming over here. And we should see it coming through. It's setting up, it's accessing the window. And I have to minimize it because it's behind it, and there we are. Still moving. There we go, move back and forth. And this is kind of cool because you can see as I move back and forth, look at the lines around my face. Especially on the difference frame, you can see where it's putting nice contours on there and setting it up. So I need to go ahead and click on one of these boxes because I moved the mouse on the other one, and then we'll push the Q button. And then we'll bring back up our OpenCV. And you can see here, every time I start and stop, it puts a start time and an end time. And we could have easily put the frame count. You can put just about anything you want on there. And I wanted to go ahead and run this one more time. And then move. Then hold still. And then click on, and then go ahead and hit the Q. And we can see here that instead of having, there we go, boom, that it picked up on a number of different start and stops on here. 1, 2, 3, 4, 5, 6, 7 start and stops. So not bad, you know, a little motion detector. Again, you can see up here where we're capturing the video. We're looping through and finding the video on each one. And then we do all of our fun transformations on creating the grayscale and Gaussian blur, anything to make it cleaner as far as counting up the threshold lines to see whether we should make it a motion or not. And then of course we tack the motion on there. We added these little boxes around the contours. That was kind of fun because you could see as I moved how it changed and there was still like this weird blur in the background. And then of course if we stop, it tags on an in value. And here's all of our displays. And voila, we have a motion detector. Or at least a start to one. You got to mess with it a little bit. And there's obviously you might want to do like every... one of the tricks that I use is where you have the static right here, is we revert to the gray static view. This one is if it's, you might just revert this to a new frame every so many frames. That kind of thing. So there's a little bit of lots of play in here that you can do with this.
Again, I want to thank you for joining us today at Simplilearn. For more information, please visit www.simplilearn.com. Get certified, get ahead.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.